Okay, good evening, ladies and gentlemen. This is Dinesh Patil here, and welcome to day two of Lean Six Sigma Black Belt Certification Hackathon. There is a training program going on, and I'm just coming from the training program, and my voice is completely gone. Okay, so what? And the training program will go till 7th, which is on Saturday. All right, so my voice is completely gone right now. So what we have decided right now, just to preserve my voice for tomorrow and for the rest of the days. Today we will be just playing the recording of the last month hackathon. Okay, this 2 or 3 hours, because otherwise my voice will completely collapse. All right, but it will not have any impact on our effectiveness of the training program. And I am available right now in the room in case of any challenge, any doubt you have. You can put it in the chat and I will be answering. Just give me a quick thumbs up in the chat box if you are with me. Is my just give me a quick thumbs up if I am audible. Just give me okay, yes. Give me a thumbs up quickly so that we can start the day two, which will be the recording. Fantastic, super. Thank you very much for the great consideration. So let me start this. Okay, we'll start from the recap of yesterday, and again this will be almost 2.5 hours of session as usual. Okay, so today we are going to cover mostly hypothesis testing, advanced hypothesis testing, and regression, advanced regression. Okay, which is covered in the black belt. Tomorrow I hope I will take care of my voice, and tomorrow we'll cover design of experimentation, which you'll learn a lot. All right. So here we go, we'll start in here. Okay, good evening, ladies and gentlemen, and welcome to day two of Lean Six Sigma Black Belt Hackathon. And yesterday, let's do a quick recap, because like our 80-20 principle. Good evening, good evening. So like our 80-20 principle, we have a principle called 86-14. I don't know how many of you know this. There is a rule called 86-14, and that rule is applied for our brain and our memory. Okay. So the memory rule of 86-14 says whatever we learn, understand, this is very important. Whatever we learn, whatever we understand, whatever we read, whatever we see first time, 86% of it gets drained on the same day. So whatever we have learned yesterday, you would have forgotten 86% yesterday only. So what is the way out of this is the revision. So what we'll do, we'll just connect the dots. We'll just start with the revision. Can you just type in the chat box the topics which we covered yesterday, if you remember? So we started with what? If you can refer to your notes, yesterday's notes quickly, we'll go through that, and then we'll start our session of the day to day. Haji. Super. Yes. So we started with CLT. Very good. Central limit theorem. Correct. So we directly went to Minitab. We generated 5. So we learned how to generate data as well, right? In Minitab, how to generate data. 5 data points, 50 data points, 5,000 data points. And then we saw that once, as we increase the sample size, then the what you can say, the distribution is naturally taking the normal distribution shape. Correct. So that is what we have seen. What else? GRR. Fantastic. Thank you very much. So we have seen MSA. We have seen the basics of MSA, measurement system analysis, which is a very important factor of this journey, which quantifies the variation induced because of the measurement system. Okay, so we have two branches over there. One is if you have continuous data, we have GRR, gauge R&R. If we have attribute data, we have AAA, attribute agreement analysis. Now we learned how to make a worksheet of that, right? According to AIAG manual, we need to have minimum 10 samples, 3 people, and 3 trials, right? So total 90 data points we should take. So how do we make that worksheet? We'd have to take the printout, randomize the runs, all the things we learned yesterday, right? Then once we collect the data, collect the result, then we start analyzing it, right? So we put the data into analysis mode. and we check the GRR value, right? So if it is between below 10%, it is a fantastic system. If it is between 10 to 30%, it is still acceptable. Above 30%, we can reject it. Okay, that is what we have seen yesterday. Plus, we have seen some graphs related to that, part-to-part variation, as well as the control chart related to that, right? Then in the AAA also similar thing, we have seen that bank wala example, if you remember, right? That bank example. So 10 files for the loan application we checked, and the 3 credit managers, right? Yeah, repetitive and reproducibility. Repeatability and reproducibility definition also we have seen, correct? So repeatability is the same person repeating the reading, and reproducibility, different people reproducing the same reading, right? So, and how do we remember? Reproducibility requires different people, right? So that's how we connect with our memory. After that, AAA, also the same thing. Repeatability, reproducibility, we have seen manual calculation. How do we calculate repeatability and reproducibility? Plus, how do we check that with the help of Minitab? So we have seen the kappa value. Kappa value is used for the AAA, right? So in the AAA, we check the kappa value. If kappa value is between 1 to 0.9, that's the best system. Between 0.9 to 0.6, it's still acceptable, and below 0.6, you can reject that value. Again, it depends on industry to industry as well. I always give this example that if you if you are a goldsmith, the measurement system is very critical for you. And if you are just a scrap trader, okay, a metal scrap trader, then that weight may not be a big deal for you, right? That variation may not be a big deal. So those things matter ultimately in the measurement system analysis. After that, what we have seen, MSA के बाद क्या देखा हम लोगों ने? So we have seen so we have seen normality and non-normal, normal, non-normal data, right? Normal probability plot. And then transformation. If the data is non-normal, how do we deal with that, right? So we have seen Box-Cox transformation, and with Box-Cox transformation, how we can convert that non-normal data into normal data, and then we have checked the process capability, correct? Everybody remember this? Just give me yes in the chat box. If you remember all this stuff, just give me yes. Super, super. Thank you very much. Thank you very much. Amazing. So let's move ahead today. We'll start with advanced hypothesis testing. So today we will cover hypothesis, advanced hypothesis, and advanced regression. Okay. As we are into the black belt, the basic stuff, let me just quickly touch upon the basic stuff. Hypothesis testing is done for So hypothesis testing basically is used to validate our assumption, correct? So generally we use hypothesis in analyze phase. So in the DMAIC framework, so EMAIC framework, so let me just remove this. In the DMAIC framework, we use hypothesis majorly in analyze phase. Okay. So we use hypothesis testing. When do we use hypothesis testing? To validate our causes. Okay. To validate our root causes, by the way. Let's be very specific. Root causes. Now, example. Let's take an example. I always give this example of in yellow belt. Sometimes I give this example. Whenever Sachin Tendulkar makes the century, India loses the game. Now, this is a hypothesis. Hypothesis meaning assumption. So we are testing our assumption with the data. So when we actually collect the data, we found that out of 49 centuries of Sachin Tendulkar, only 12 matches Indian cricket team has lost. So 12 losses out of 49 centuries. And still we are saying whenever he makes a century, India loses a game. So it is not getting validated with the data what we have in our hand. So that hypothesis is not validated. So here what we do, we whatever are the root causes are still our assumptions and our experiences, our opinion, our hunches. Those have to be still validated with the data, because Six Sigma is a statistical based methodology. It's a data based methodology. We don't believe in anything but only and only on data, right? So what we do here, we collect the data, whatever is the root cause. Okay, we validate that root cause with the data, and that's where hypothesis testing comes into picture. Now, in the green belt level, we have seen what is hypothesis. We have seen, there are two types of hypothesis. Can you just type in the chat box what are the two types of hypothesis? There are two types of hypothesis. We know, right? What is that? Two types of hypothesis. Type in the chat box. Yeah. Very good. Null hypothesis and alternate hypothesis, right? Null and alternate. Remember that, everybody? So one is null hypothesis, which is HO, and other one is alternate hypothesis, which is HA. Okay. So null says it is called as statement of equality. Statement of equality, it will say that both are equal, and alternate will say statement of difference. Statement of difference. So these are two exactly opposite statements here. So let's say we are comparing two vendors, and the average of first vendor, we are saying in the null hypothesis that average of the first vendor and average of second vendor are same. The second, the alternate hypothesis says average of first vendor is not equal to average of second vendor. And then we collect the data, we put the data in the software, and we check a value called, which value do we check? Type in chat box, everybody. I hope you have been to the basic ones. Okay, yes, very good. So we check the p value, right? And then we have a rhyme which says p low and null go. That means if the p value is less than 0.05, then we reject null hypothesis, right? That's what we have seen in the green belt level. Everybody knows this, correct? So p low, null go, that is what we have already seen. So what we'll do now, in the green belt level, we have two different types we have seen. One is called one sample t-test. Other one is called two sample t-test. How many of you remember that? Just give me yes in the chat box. Green belt, we have covered the basics of hypothesis and one sample and two sample t-test. Just type me in the chat box if you remember. Correct? Yes. Very good. Very good. Very good. Let's do one thing. Let's do one thing. We will do a quick revision on Minitab, a small revision of green belt for our two sample t-test. Okay, just a second. So let me just quickly share this file with you. Can I just download this file of two sample t-test? उसका एक revision quick कर लेते हैं. Let me explain you what is this t-test, and then we will see how this p-value is calculated. I'll give you another example as well. Okay, once you open the file, please let me know. The name of the file is two sample t-test. These are the same files. Okay, I always share twice. So if your internet is not maybe fluctuating, etc., then you can. All right. Once you opened it, let me know. So this particular file is basically, meanwhile, just see this file. There is one column called male CCOs and second column called female CCO. Now CCO stands for call center officers. Okay, call center officers. Now So they want to check what is there any difference between the male call center officers, the turnaround time of call closing, and female officers call closing turnaround time. So what is this number? It is in minutes. Okay. So the first male employee has uh, sorted the query of the customer in 13 minutes. The next one is 10 minutes, 11 minutes, 12 minutes, etc. And here you have got female call center officers, resolution time. So what they will do, they will just take X bar, of male and X bar of female. So this is null hypothesis, which says both are same, and alternate hypothesis will say no, there is a statistically significant difference between these two, right? So once you opened it, let's go to this one sample. Sorry, this is called two sample t-test. Okay, two sample t-test. So let's go for two sample t-test. Go to stat, basic statistics, two sample t-test. Everybody follow this process. Again, this is just a revision of the green belt itself, just to brush up the foundation. Go to stat, basic statistics, two sample t-test. Once you click on that, once you click on two sample t-test, this window will appear. So here in the drop down, it says both samples are in one column. Just click on that. There are three options you have. Second option is each sample in its own column. Third is summarize data. So in this case, because we have each sample in its own column, so we'll select the second option, each sample in its own column. I repeat again, go to stat, basic statistics, two sample t-test, which is the sixth option available. Click on that, select each sample in its own column. In sample 1, select male CCO, sample 2, select female CCO, and just click on OK. Wow. So what we have got here, just try to understand. All right, just try to understand what we have. So see, male average, let's say X bar M basically was 11.63. Okay. And female average was 12.80. Correct? That was the, so here we can say mathematically there is a difference of 1.17, I believe. Yeah, 1.17 minutes. Correct? This is a mathematical difference between the two averages. But in hypothesis testing, what we are checking is this mathematical difference, 1.17, is it statistically significant for the population? That is what we are basically checking. This 1.17 difference, is it statistically significant for the long term? Is it statistically significant for the population? Because we have taken very limited data. Correct? So here the p-value is what? What is the p-value? You can see the p-value here, which is p-value is 0.044. Now tell me, is it lower than 0.05? Just give me yes or no in the chat box. Is it lower? Very good. It is lower, right? So that means P low and null go. That means we have to reject null hypothesis. So what was null hypothesis? If you remember, X bar male is equal to X bar female. That was a null hypothesis. And alternate was X bar male is not equal to X bar female. That is alternate. So we have to reject null and accept alternate. That means there is a statistical significant difference between these two. Are you clear with this? Just give me yes in the chat box. Clear hai ye? Just give me yes. Now this was covered in the green belt level. Correct? This was covered in the green belt level. Now let's go a little deeper into the black belt level, understanding and decoding the p-value. P-value is called a probability value. Okay, now just listen to me very carefully. I'll give you a graphical representation of this. Let's say, for example, if I plot the male data distribution, imagine the average is, let's say, 11. Imagine, okay, just for our simple understanding. And then I plot the female data distribution like this. Imagine the average is 12, just for our simple calculation. Now, this, if both these averages, so this is X bar M and this is X bar F, there is an overlapping area, if you can see here. This overlapping area actually is nothing but this P value. Okay. Now try to understand this. When we say 0.04, okay, you just multiply that 0.04 into 100. What will happen? It will be 4.4. Can you see? What is 0.04 if you multiply 0.044? No? Into 100. If I do multiplication, it will be 4.4 percentage, let's say, for example. Okay. So that means, understand this, this area is very less. Actually, this should have been a little wider. Okay. So this overlapping area is what is this, we are checking the P value. If this, the total area of this entire, this is entire total area is 100%, only 4.4% is overlapping area. If this overlapping area is less than 5%, that means the distance between the two averages is significant. Try to understand this. I will just draw it a little differently. Let me just give me a second. I'll just draw it a little differently. Okay. Let me take the actual values here. First one is 11.6, let's say, for example. Now it should be like this. This is a better representation. And this is 12.8. These are the actual values. Okay. This is X bar M and this is X bar F, which is female average. And this is a small area which is overlapping. Ultimately, this is my P value. All right. So understand this. If the moment the P value is less than, so the P value is the percentage area is 4.4%, right? Which is nothing but 0.044, correct? Now, when the P value becomes less than 0.05, which is 5%, out of 100%, the overlap is only 5%. That means there is a statistically significant difference between these two values. And let me draw another diagram. Imagine the let's say, for example, let's say female, then we give a special training to the female. And now female also have come 11.8. Now what will happen? They will shift on left hand side, right? Let's say female average has improved. That means within a smaller amount of time, lesser amount of time, they are solving the query. Okay. So now how it will look like, just try to understand this. Let's say if this is the male average, which is 11.6 only, let's consider this X bar M. Now, because the female average has reduced, it will come like this. Let's imagine this is, let's say 11.8. Let's imagine that way. Okay. Earlier it was 12.8. Now it is 11.8. Now this is X bar F. Now you can see more overlapping area between these two distributions, correct? Now, when the area is more, earlier area was only 4.4%. This might be around 30%. So whenever that area is more than 5%, that means very less significant difference between the two distributions. Are you clear with this analogy? Just give me, just type yes in the chat. Very simple, simple to remember. Just give me yes. Understood this? With the same example of male CCOs and female CCOs. So you always remember this way, the p-value is the overlapping area. Okay. And software has the algorithm fade into that. So it basically identifies this. Now, do you want to calculate the p-value manually? I'll give you one example so that we can calculate p-value manually as well. Are you interested so that I can tell you? Otherwise, we'll move on to the other segment. Manual p-value सीखना है? Okay, very good. Chalo. So what we'll do, I will just take one example of manual p-value. Okay, now we are observing one sample t-test here, right? One sample t-test, correct? Now, what is t-test? T-test basically referred to a distribution called t-distribution. Now, this t-distribution is a little flatter distribution than our normal distribution, because remember yesterday when we were learning CLT, our central limit theorem, we gave you a number. You should at least have that many data points. What was that number? Type in the chat box. How many data points we should have at least to get a normal distribution like this? Very good. 30 data points. Absolutely right. So to get our normal distribution, which is also called as Z distribution. Okay. So we should have 30 data points. So whenever we have 30 and above, we can go to Z distribution. But if we have less data points than 30, in this case, we only have 10 data points, 8 data points, etc. So we can take help of T distribution, which is similar to Z distribution, a little flatter. If we increase the sample size of T distribution naturally takes shape of Z distribution. That's the only difference. Okay, just a basic information about T distribution. There was a statistician whose nickname was Student, and from his name, the distribution T has been given the name. Okay. So now I will give you one example to calculate the p-value manually. Okay, just take this example. there is one company, let's say for example, and we have the carton boxes. Basically, if you remember, whenever we get any package from the courier, we have a carton box, like a paper box, which is a strong paper, just like whenever we purchase a refrigerator or an air conditioner or a television set. So the box which comes, that is called a carton. Okay. Now, let me give you one data set so that we can. So there is a standard mean here. Okay, which is, just write this down in your notepad, 1.84 kilogram. That means the vendor is claiming that our average weight of our box, our carton, would be 1.84 kg. Okay. Then what they do, the company, okay, the customer company, basically their engineers take some sample. So the sample size here, they take 64 samples. sample size is 64. All right. So they found that the mean, actual mean here, actual mean of those 64 cartons found to be 1.88 kilogram. Now understand this. The vendor says the weight would be 1.84 kg of the box. They take 64 samples and they weigh all the 64 samples and they take the average weight, which comes out to be 1.88 kg. Okay. With standard deviation of 0.3 kg, right? Yeah, I think yes, super. So now try to understand this. So what is this? Standard mean is nothing but mu. Sample size. If you can pull out a calculator, we'll just calculate this manually first. Sample size is n, as we all know, number of data points. Actual mean is x bar, and standard deviation is sigma. Okay, super. Now, first, what we will do, there is a now because there's a sample size is 64, which is more than 30 data points, instead of t distribution, we can use z distribution. Okay, we can use z distribution. So like one sample t test, we have one sample z test as well. Okay, so there is a z calculation we need to do first. The first data we need to calculate is z calculation, which is the formula is x bar minus mu divided by standard deviation, which is standard error of mean. Okay, sigma divided by square root of n. So can you just put the value? X bar is what? 1.88. Can you just pull out the calci and do this quickly? Divided by standard deviation is what? 0.3 divided by square root of 64, which would be 8. Can you give me the answer of this? Meanwhile, I'm sharing a table with you guys, okay? Statistical table. Usko download kar lijiye. Please download the statistical table just for our calculation. Okay, so we are manually calculating the p-value. How this p-value basically? They have standard deviation, they have calculated. Like they have taken the mean, no? So with the same data, they can calculate standard deviation, no? Sigma. What is 0.4? Standard deviation of those 64 samples, the weight of that is 0.3 kg. So you have to calculate first the z calc. Once you calculate the z calc, then we will calculate our. So these are already given values. So we haven't calculated anything. These are given values to us. Okay. Now first you calculate the z calc. Yeah, what is the z calc right now? Everybody calculate this and give me the answer. 1 point. There's something 1 point. I'm just waiting for everybody to give the answer. Huh. Very good, Ravindra ji. Very good, very good. I'm just waiting for others also to calculate this. फटाफट calculate करो and give me the answer. Very good. Is it 1.06? Everybody got the same answer? Z calc का आंसर सबका सेम आ गया है? Just give me yes. 1.06 ऐसा ये कुछ है? 06 या 07 whatever. Give me yes, no in the chat box quickly. Yes, very good, very good. So what do we do after this? After we calculate a z-calc value, just understand this. Just open that table, statistical table which has been given to you. उसको जरा डाउनलोड करिए statistical table को. Once you open the statistical table, we have various different types of tables here. Just like our log table we used to use in our colleges, correct? So we have here cumulative normal distribution, which is Z distribution, then T distribution, F distribution, chi-square distribution. So we'll understand it later. Let's talk about Z distribution because we are talking about Z distribution right now. So just scroll down. So here you will find this. Now, see, all these numbers are basically calculated with the formula of area under the curve. What is that? Area under the normal distribution curve, right? Normal distribution curve. So the value what we have calculated is z-calc value. This is that value, and the area on the left hand side of that will be calculated here. Okay. So what was our value? 1.06. So if you see here, there is a z. Okay, let me just quickly increase that size of it a little so that you guys can also see it very clearly. Okay, right now, look at this. So we have, yeah, you can see here the z value of, so this is the, just see the vertical one. So 1 point, so you can just see this row, 1.0 and 0.6 on the horizontal, you can see here. So here you can come just horizontal, and on the other one you can come vertical. Okay, so you will find out this value 0.8554. Yes, everybody got it? 8. Okay, उसका ये क्या था? What was the 1 point? What was the value? Basically 1.0666 था क्या? If it is more than 5, then what you can do? You can round it off. If it is 6.7 or 6.8, let's say for example, what was the actual value in second? What was the third digit after 0.6? Ravindraji, did you calculate this? What was the value after 1.06? If it is more than 5, then you can consider 1.07. That will be better. Okay, yeah, it was 1.066. Okay. So you can consider 1.07. In that case, you can consider this one. 1.0666. Very good. So in that case, we just round it off to 1.07. In that case, just see this value, and this value will come this 0.8577. Are you clear? So this is the horizontal line, 1 wala, and this is 0.07 wala line, and this is coming to 0.8577. So actually this area, basically what we are is 85.77% actually. Okay. Are you understanding this? And what basically we are looking at is this area, which is the p-value. Okay, in this case. So the p-value is nothing but 1 minus 0.8577. So what will be the answer? It will be 0.1423. ऐसा कुछ तो आएगा, 0.14. Now, if the p-value is 0.14, let's say, example, the p-value is 0.14, what will be your conclusion? If the p-value is 0.14, what will be your conclusion? P low, null go, right? Is the p-value lower than 0.05? Is the p-value lower than 0.05? The answer is no, exactly. So in that case, we have to accept null hypothesis. So there is no statistical significant difference between the two values. What were the two values? If you remember, the mu, which was the standard given, was 1.84 kg and the x bar was 1.88 kg. Even though there is a small difference of 0.04 kg, but that is not statistically significant. That's what this p-value is telling us. Clear? Just give me yes in the chat box. Understood? Just give me yes. Now what we will do, we will just quickly we will do it in the Minitab software as well. Okay. We'll go back to our same Minitab sheet. The male CCO, female CCO में फिर से जाएंगे. Go to stat. Let's do it in Minitab. Go to stat, basic statistics. Stat, basic statistics, one sample Z test. Can you see here? Just above one sample T, we have one sample Z test. Once you click on one sample Z test, here, select summarize data. Select summarize data. Summarize data because we have, you know, the standard value, the actual value, the standard. So all summarized data we have. So we don't have the data sheet as such. Imagine if we would have the 64 weight samples data, then we would have selected this option. But we have instead we have summarized data. So click on summarize data. Now here the sample size is right to 64. Sample size is 64. The sample mean is 1.88. Standard deviation is 0.3. Click on perform hypothesis test, and hypothesize mean is 1.84. Everybody just put these values. Just put these values. Let's go to stat, basic stats. In basic stats, there is one sample Z test. Select summarize data. In summarized data, sample size 64, sample mean 1.0888, standard deviation is 0.3. Click on perform hypothesis test and put 1.84. Now go to option. Go to option and just make a small change here because actual mean is 1.88, which is greater than the sample mean 1.8, right? So mean is greater than hypothesized mean. So this is what we know. So we'll select this. So there are three options. One is mean is less than hypothesized mean. Second is not equal to. And third is greater than. Because we already know the values, we can select mean is greater than hypothesized mean and click on OK and click on OK. Now we can see here one sample Z test, all the statistics have appeared. So what was the null hypothesis here? Null hypothesis was X bar sample is equal to X bar, or you can say mu of standard, right? And alternate hypothesis was X bar sample is not equal, in fact greater than X bar standard. This was our alternate hypothesis. Okay, because we already knew the data, that's what we have kept that way. Or you can say it not equal to as well. Okay, now because the p-value is 1 point, can you see the p-value here? P-value, as we have also calculated manually, 0.14, which is greater than 0.05. So we cannot reject null hypothesis. So we are saying there is no statistical significant difference between sample and the standard. Okay, you can see the calculated Z value also 1.07 and the P value 0.143. Clear? Just give me yes in the chat box. So this is how we can calculate this manually as well. Just give me yes. Super. All right. Very good. Very good. Super. Super. Amazing. Now, let me take you to some of the other factors here. So we have seen one sample t-test, two sample t-test in the green belt. We have seen two sample t just now, and we have learned one sample z-test as well. Okay. So these are some additional hypothesis testing we have learned. Let me quickly check. Okay. So let me just share my screen with you guys. So in your black belt curriculum, just look at this, you know, hypothesis testing tree. Okay. In this hypothesis testing tree, you can see there are three types of hypothesis testing basically we are doing. The first one is basically about the mean. So if I draw, if I draw this distribution, if I want to compare, understand this. If I want to compare averages with averages, that is called comparing the means of the distributions. That's where this part, the basic, the foundation part comes into picture, where if you are comparing the average of one sample with the standard, that is called one sample t-test. If you are comparing two samples with each other, that is called two sample t-test. There are another two ones which are called paired t-test and ANOVA. If you have more than two samples, then to compare, let's say there are three processes, four vendors, five players, okay, or three shift operations, then we go for ANOVA. And there is another one which is called paired t-test we are going to take. Okay. Apart from that, if I want to compare between variances, the variability or standard deviation, variance or standard deviation. So we have this one, okay, F ratio test and test of equal variances. So one is the mean. One is the mean, and second is the standard deviation. Standard deviation measures the variability, right? You can compare the variability of two vendors as well. Two vendor, whether the standard deviation of one vendor and standard deviation of two vendors, is there a statistical significant difference? That also you can check. Okay, that's where F ratio test and test of equal variance comes into picture. There's a third one which is proportion data. What is proportion? Let's say rejection. Out of 100, you have rejected, let's say 10. That is called 10% rejection. Now you want to compare this proportion rejection shift-wise. If you want to compare with two samples, that's where test of two proportion comes into picture. If you want to compare more than two, then chi-square test comes into picture. Clear? Let me repeat. Three major types of hypothesis. One is mean. Second is variability. Third is proportion. Okay. So in mean, we have one sample t-test, two sample t-test, ANOVA and paired t-test. In variability, which is second one, we have F ratio test. If you want to compare two samples variability with each other, F ratio test. If you want to check more than two, go for a test of equal variance. Okay. And then third one is the proportion. If you want to test the two samples proportion with each other, then go for test of two proportion. If you want to test more than two samples, go for chi-square test. Are you clear? Just give me yes. This is already given in your curriculum as well. Yes, very simple. You can easily remember this as well. So now what we'll do, we'll go for paired t-test and ANOVA in the mean itself. Then we'll go the other factors. Okay. So I'm just sharing one data with you about paired t-test. Okay. एक बार उसको download करिए and then we will open that. When do we use paired t-test? That also I will explain. Okay. Just open this file and let me also open it. Okay. Yeah. So when do we use paired t-test? Just try to understand this. Now, two sample t-test is what? There are two different samples compared with each other. Like the average of Rishabh Pant and average of KL Rahul. So you are comparing two different samples with each other. That is called two sample t-test. Okay. Now here, if we have a common sample tested against two different scenarios, understand this? The common specimen, the common sample tested against two different scenarios, it's called paired t-test. Example ke liye, let's take a small blood sample and you are testing the sample in the old blood analyzer and the new blood analyzer. The sample is common, the sample is same, but you are testing against two different scenarios. You are checking your weight at your residence or at your gym. You are a common weight sample, but you are testing the weight at two different scenarios. That is called as paired t-test. Are you understanding this? If the samples are distinct, samples are completely different, then we are using two sample t-test. Here, the sample is common, tested against two different scenarios. Are you clear with this? Just type yes in the chat box. Just give me yes. Another example could be, let's say Yashasvi Jaiswal is a very young cricketer. So Yashasvi Jaiswal's performance under Virat Kohli's captaincy and Yashasvi Jaiswal's performance under Rohit Sharma's captaincy, that will become paired t-test because the sample is common, Yashasvi Jaiswal, tested against two different scenarios. Are you understanding? Just give me yes in the chat box. Clear hai? Scenario clear hai? That is called paired t-test. Just give me yes. Okay? Yes? Very good. Now here, the same thing, the blood sample is tested against old analyzer and the new analyzer. So how do we do that? Go to stat, basic statistics. Here you can see paired t-test. Okay. So under two different conditions, just select paired t-test. Remaining everything remains exactly same. Okay. Sample 1 may select old analyzer, sample 2 may select new analyzer, and click on OK. Yeah, I will share this file. Huh? Check the p-value, which is 0.003. So the fundamental remains same. Now we know how the p-value is calculated as well. So we just can do it a little faster. मैं एक बार फिर से शेयर करता हूँ pair t-test का फाइल. Okay, दो बार शेयर करता हूँ. So here the p is low, right? 0.003. So p is lower than 0.05. That means the null hypothesis has to be rejected. P low, null go. That means there has been a statistical significant difference between new and the old analyzer, right? Yes. Clear? Eh? So this is called paired t-test. Got it, everybody? Simple. Understand the scenario. Now, when we have something called more than two samples, like 3, 4, 5, 6, 7, then we go for something called ANOVA. So I'm just sharing a file of ANOVA. Now, whenever we have more than two, let's say 3, 4, 5, 6, 10, 15 samples we want to compare with the means. I'm talking about only means, the averages. Okay. That's where ANOVA comes into picture. So just check this. I'm also opening the file of ANOVA. ANOVA is the full, it is a short form of analysis of variance. ANOAN, which is analysis, O for off, and VA stands for variance. Okay. So here, if you open the file, please let me know. Meanwhile, let me just share this screen with you and try to understand the scenario. Okay. So there are 5 zones here. Okay. So let's say there is a Mercedes showroom. There are 5 zones. or 5 service centers, you can say, and they have taken every center's average 5 data points to complete the servicing of the car. So first car requires 5.3, second car requires 5.2, 5.4 hours, okay, of servicing. So they want to check whether there is any statistical significant difference between. So the zone 1, so they will calculate the average of zone 1, and that will be x1 bar, okay. Zone 2 would be x2 bar, then x3 bar, x4 bar, and x5 bar, okay. And the null hypothesis will be all are equal with each other. There is no statistical significant difference. And alternate will be at least one has some different average, the significant different average than others, okay. So we just want to check whether there is any statistically significant difference between these numbers, okay. So how do we do that? Go to stat ANOVA one way. Everybody follow this. Stat ANOVA one way. Stat ANOVA one way. Click on that. In the response, select the lead time, and in the factor, select the zone. Response में lead time को select करो, factors में zone को select करो, and just click on OK. First, you will get this graph, first of all. Okay, so what is your observation about this graph? Now, these are the 5 zones data, and these are the averages, if you can see. These are the average values. Okay, and these are 95% confidence interval, if you know that, right? 95% CI, which we have already discussed, right? So, but what is your observation here? Give me your observations. Very good. So zone 2 average is a little higher than the others average, right? Can you see here? Zone 2's average is almost 5.45, whereas others are very close to 5.3. Correct? So zone 2 has some challenge. Now let's see, is there a statistical significant difference? So we go to the sessions window, right? Sessions window. Click on sessions window here, this one, or you can just click on Control Alt M and just scroll up, and here we will find a p-value. The p-value is 0.018. So which is obviously lesser than 0.05. So P low, null, go. So we have to reject null hypothesis and we have to accept the alternate hypothesis, which is there's a statistical significant difference between these, these. So, and we know that, the zone 2 has a challenge, correct? Zone 2 has a challenge. So what we can do here, now what we will do, we'll just remove zone 2. Let's see if we remove the zone 2 data. Okay, so zone 2 का data हम लोग delete कर देते हैं data file से. Okay. Now if we do the testing once again, let me check. Wow, look at this. The moment I remove zone 2, the graph has changed. And now let me check what is my hypothesis testing p-value. Wow, look at this. See, the p-value has changed to 0.864. Significant change in the p-value can be seen here. That means the difference maker was zone 2 only. The moment I removed it, now there is no statistical significant difference between 1, 3, 4 and 5, right? इनमें कोई statistical significant difference नहीं है, only 2 में था. That means 2 requires some special attention to reduce the lead time for servicing. Clear? Just give me yes in the chat box. Understood this one? And this is called as ANOVA. Where can you use ANOVA, by the way? Where can you use ANOVA? Type in the chat box. Where can we use it? In your process to compare more than 2, what you can say, samples. For example, 3 shifts. Yeah, more than 2, anything more than 2. Even for 2 also you can do ANOVA. Correct? Right? Very good. So 3 shift operations, say 3 products, 4 products, 5 products, 10, 15, 20. There is no limit. Daily quality check. Very good. Shift data, production you can compare. Rejection you can compare. Sales you can compare. Daily sales you can compare. Okay. Or sales manager type, what do you say? Sales manager wise performance you can compare. Very good. Very good. So clear? Super. Now, let me share my screen with you. Let's move ahead. Once we have seen same product purchase of different vendors. Very good. You can compare that. So we have seen 1 sample t-test, 2 sample t-test, pair t-test, ANOVA, 1 sample z-test as well. Let's move to the variability part. Okay, starting with, if you want to compare variability, which is variance or standard deviation of 2 groups, we'll go for F ratio test. Okay, so let me give you one scenario here. A random sample, now just try to understand this. A random sample of 12 and 16 are drawn from the population. The sample standard deviations are found to be 145 and 82. Okay. Test to see is there any statistical significant difference between these two. That means, for example, so there are 2 samples they have taken. Sample number 1, let's say N1, and sample number 2, N2, right? So there are 12 data points, there are 16 data points here. And the standard deviation is 145. For this, the standard deviation is 145, which is small s. And so S1 I will write. And standard deviation for this is 82. Okay, so if I have to draw, it would look like this. Okay, a little flatter curve. So the first one is having 145 standard deviation. Second one is having 82 standard deviation. So this would be 145 standard deviation. This would be 82 standard deviation. Now we want to compare, is the difference statistically significant? Are you clear? See, before that we have compared the means of 2 samples. Now we are comparing the standard deviations of the 2 samples. Are you clear? Just give me yes in the chat box. Standard deviation is a measurement of the variability, right? Now we are checking, we are comparing variability against variability, right? So now how do we go about it? Let's open the same file. The same file, we will go for the same file. Go to the, stat. Basic statistics. 2 variances. Go to stat, basic statistics, 2 variances. Just go there. Go to stat, basic statistics, 2 variances. Now, whenever we want to compare 2 variances, we'll go here. Now, just drop down each sample in its column, samples. Yeah, just select sample standard deviation because we know sample standard deviation data, correct? So select sample standard deviation. Now here, just come, just follow this. Uh, sample size kya tha? First sample size was 12. Second sample size was 16. First standard deviation was 145 and the second standard deviation was 82, I believe, right? 82. Yes, everybody got it? Now the remaining fundamental remains. Just we have to check the p-value, that's it. Okay. So what is the null hypothesis and alternate hypothesis here? Null, just a second. So null hypothesis will say that standard deviation of S1 is equal to standard deviation of S2. Alternate will say standard deviation is not equal to standard deviation of sample 2. Okay. Now we will just click on OK and check the p-value. Wow, look at this. So the p-value is here. You can see the p-value is 0.043. Very, very close to 0.05, but still it is less than 0.05. That means P low null go. We have to reject null hypothesis and we have to say that there is a small statistical significant difference between these two sample standard deviations. What is the relationship between variance and standard deviation, guys? What is variance and standard deviation? What is the relationship? Standard deviation equal to square root of variance. So variance is what? Sigma square, right? So standard deviation is square root of sigma square, which is sigma, right? So variance and standard deviation is the same thing basically, correct? So one is the average, the central tendency. The second is the variation. Okay. Yeah. Where do we get this sample size 12 and 16? It is given in your one of the example. Okay. आपके फॉर्मूला में मैं आपको दिखा देता हूँ. There is a formula given. So there is an example given in your. We'll see here. So I have taken this F ratio test, F test basically. So this is the example I have taken. N1 is equal to 12, N2 is equal to 16. Okay. Clear? Now, whenever we have more than, what do you say, more than 2 samples, that's where we use, what you can say, we use this one, test of equal variances. Okay, I'll show you when to use test of equal variances. Let me go back now here. So we have seen, if I want to compare variability of one against variability of another. Okay, if there are 2 samples, I will go for F ratio test. But if I want to compare 3, more than 3 or 4 or 5, then I will go for test of equal variances. Okay, so the same. See, you can easily understand this. 1 sample t-test, 2 sample t-test, more than 2, go to ANOVA. Here, F ratio test. If you have 2 samples, go to F ratio test. If you have more than 2, go to test of equal variance. If you have 2 samples, 2 proportions, go to 2 proportion test. If you have more than 2, go to chi-square test. That way you can simply remember this sequence. Okay. Now, coming back to this one, test of equal variance, let me share with you a file, which is the same file what we have seen the Mercedes showroom wala file. Okay. But let me share that file once again, which is the test of equal variance. Okay. ये तो सेम ही फाइल है, तो zone 1 वाला, zone 1 zone 2. Can just open this file quickly. The same ANOVA wala file, that also you can use. Or you can use this new file as well, according to you. All right. Now, let me also open this. Okay. Once you opened it, let me know. Test of equal variance. Now, for the same ANOVA example, in the ANOVA example, we compared averages of 5 zones, right? Now, for the same data, we are going to compare the averages. So similar kind of data, we are going to compare the averages of, not averages, the variances of all these things, okay? So it's called as test of equal variances. So here you can see, oh, just a second, let me share my screen, which has not been shared. Yes, here we go. So I'm sharing my screen right now. So here you can see, earlier we compared what? X bar 1, X bar 2, etc., right? So now we X bar, instead of that, we are going to compare what? The variances. Okay. So variance is shown as this symbol, sigma square, right? So we are comparing sigma symbol, sigma square A, sigma square B, sigma square C, D, and sigma square E, correct? So what the null hypothesis says, all the variances are equal. The alternate will say there is a statistical significant difference between the variances, right? So let's do this. Find out whether there is a statistical significant difference. Go to stat ANOVA test of equal variances. Just follow this. Stat ANOVA test of equal variances. Stat ANOVA test of equal variances. Once you click on that, in the response, the response is our lead time and our factor is the team, which is A, B, C, D. And click on OK. Wow. Look at this. Now, the p-value here, the multiple comparison, the p-value is 0.385. When the p-value is greater than 0.05, so we cannot reject the what you can say, null hypothesis. So there is no statistical significant difference as far as the variance is concerned. Are you understanding? There is no statistical significant difference as far as variance is concerned. So we can say there is no statistical significant difference. Clear? This is how, if you want to compare the variation between 2, 3, 4, 5 groups with each other, you can use this test of equal variances. Clear with this? Just give me yes in the chat box. Once we do that, now we will go for the proportion test. So we'll just quickly check test of 2 proportion and then chi-square test quickly. 11th p-value is where if you have non-normal data, then we'll go for 11th test. Okay, if we are dealing with a non-normal data, okay, the skewed data, then we'll check the 11th test. But if you see, both the tests are showing greater than 0.05, whether it is normal or non-normal, both are 0.05. So anyway, there is no statistical significant difference. Okay. Now let's go to test of 2 proportions. Yeah. So all these things, with examples, with p-value, everything has been given. Okay. So let's go to test of two proportion. All right. Now here, a corporation's purchasing manager. Yeah. So let's see, corporation purchasing manager need to authorize a purchase of 20 new photocopy machines. Okay, so they want to purchase a Xerox machines, I would say. After comparing, it's a big corporate office. Okay, many brands they compared and they finalized two brands, brand X and brand Y. All right. Now, because they already have this brand X and brand Y in their offices, in various offices, they collected their performance. Okay. So random sample of 50 machines for each branch were selected. So 50 samples of brand X and 50 samples of brand Y were selected from their other offices. They found that 6 brand X machines and 8 brand Y machines need servicing. So it is like this: X brand and Y brand, 6 out of 50 and 8 out of 50 requires the servicing. Are you understanding? So we want to check whether this proportion has any statistical significance or not. There is a proportion here. Now this proportion, so null hypothesis will say both are equal. Alternate will say both, there is a statistical significant difference. Okay. So how do we deal with this? So let's go to the same file, open the same file. Okay, test of equal variance wala file we can still use. Now we'll go to just a second. Okay, we'll go to stat, basic statistics, and test of two proportions. Okay, here you can see the two proportion data. Everybody just go to stat, basic statistics, the two proportion data. Stat, basic statistics, two proportion data. Click on that. Now here we will just enter summarize data. Just select summarize data. So number of events. What do you mean by number of events? How many, how many basically, what you can say, the data of that particular X was not working. So I think there were 6 machines were not working out of 50. And for sample 2, 8 machines were not working out of 50. 50, right? So 6 out of 50 and 8 out of 50, we just want to compare two sample proportion and click on OK. And just check the p-value, which says 0.564, which is clearly indication that the p-value is greater than 0.04, 0.05. That means there is no statistical significant difference. So you can purchase any brand, either you check X or Y, there is no statistical significant difference as far as the proportion is concerned. Okay, there was a small difference, but that is not statistically significant. That's what this test is telling you, right? So if you are a purchase manager, you can go to either of this brand. Yes, clear hai ye? Just give me yes in the chat box so that we can go to. Very good, super. Now, if you want to compare more than 2, then there is something called chi-square test. Okay. So for example, let me share with you where do we use chi-square test. So they have collected a scenario that shift-wise defect data they have collected. So first, I will just quickly tell you how the chi-square is manually calculated, chi-square value. We'll just take a couple of minutes to do that. And then we will do it with the help of Minitab software. Okay, then we'll take a quick break, right? Now, just the scenario is, we want to know if the shift has an influence on the number of customer complaint generated in the company. Okay, so there are shifts A, B, C shift, first shift, second shift, night shift, and shift-wise defect or customer complaint data they have collected. Now they want to check whether shift has any influence. For example, sometimes in the night shift, there could be some kind of lethargy. Okay, because people would be sleepy, they would not be in their complete consciousness, etc. They can skip some of the defect, and there could be some more customer complaint. That can be a hypothesis, right? So they want to check, right? So they will go for chi-square test. So first is they have collected the data like this. Okay, so shift 1, 2, 3 in the vertical column. In the horizontal column, A, B, C, D are the types of defects. Okay, so shift 1 has 15 A type defect, 21 B type defect, 45 C type defect, and 30 D type defect, etc. So they have collected this data into this matrix. Okay. Now, how they calculate a chi-square? There is a little complex formula to calculate chi-square. Let me just quickly explain you this. So first they calculate expected value. Just try to understand what is expected value. Expected value, the formula is row total into column total divided by grand total. Okay. See, do we have to remember all these things? The answer is absolutely no. But do we have to know this? Answer is absolutely yes. Okay. So just understand it. No need to by heart it or remember this for a very long time. Just understand it. Now, what is the row total? Just try to. Row is what? Horizontal. Column is the vertical, right? So let me just make it a little blue. So here, what is the row total? So 15 plus 21 plus 45 plus 13 is equal to 94. That is called a row total. And what is the column total? 15 plus 26 plus 33 is equal to 74. That is a column total. And what is the grand total? If you add all the row totals and the column totals becomes the grand total, which should match. So if I add all the row total and the column total, it should basically add to this. So this is 309. So what is expected value? For example, I want to calculate expected value for 15. What will be that? So row total will be, just for our understanding, okay? Row total will be 94 because 15 ka row total is 94 and 15 ka column total is what? 74, right? So 94 into 74 divided by grand total, which is 309. So whatever is the value is the expected value of this 15 value. So they will calculate actual and expected, actual and expected, actual and expected for each and every data point. Okay, so let's move ahead after understanding this. So once we calculate this, let's say, here we go. 94 row total, 74 column total divided by 309 grand total equals 22.51, which is expected value. Actual value 15 hai, expected is 22.51. So let me show you a table here. They have calculated for each and every actual value. They have calculated the expected value. You can see here. So 15 was the actual value. So expected is 22.51. Similarly, 21 was the actual value. Expected was 20.99 with the same formula. Row total into column total divided by grand total. Okay. So then this entire matrix is calculated. Now they calculate a chi-square. What is the formula of chi-square? This is a chi-square. Again, chi is a Greek letter, just like alpha, theta, delta, gamma. Chi is also Greek letter. So chi-square is equal to observed minus expected. Observed is the actual value. Expected is what we have calculated divided by expected. So observed minus expected is to square. divided by expected. So this is how, for example, you can see here 15 minus 22.51. We have just calculated that, right? 15 is the actual value, 22.51 is the expected value. Uska difference ka square divided by expected value, which is 22.51. So they have taken for each and every value and they have summed it up. That is a chi-square which is 19.18. So from the chi-square, we have to calculate, we go to chi-square table and then we'll calculate the p-value. Okay, now I will just give you a Minitab file. We will directly do it with the help of Minitab directly. Okay, so let me share with you the chi-square test example. Okay, can you just download this file quickly and open this? The same file, this same data. We will do it with the help of Minitab. All right, once you open it, let me know. File open. Yeah, the same data point, or you will find out over there. Okay. Let me also share my screen. Done, open. Very good, very good. So now the same data you can see here, shift 1, 2, 3 and A, B, C, D. The same values have been taken, correct? Got it, everybody? Super. Now here, a little different approach has to be taken. Go to stat, tables. And cross tabulation and chi-square. Go to stat, tables, cross tabulation and chi-square. Just open that. Now there are multiple options. Just go to drop down menu. Now because we have a summarized data in the two-way table. See, understand this. If we want this data to be used, A shift, A shift, A shift wala data, then we can use the first option. But because we have a summarized data in this table, two-way table, two-way meaning shift and defect. Shift is one way and defect is the second way, right? So two-way table ka ye hai. Isliye we will go for cross tabulation chi-square. We will select a drop down the second option. Okay. Now in this column containing the data, we will select A, B, C, and D. I've just double clicked on that, A, B, C, D. Because in the columns, we have A, B, C, D data, and in the rows, we have the shift data. Okay, just select the shift. Do not select the shift number. Shift number is this column, which we are not taking. C1 column we are not taking. We are taking this shift. Shift 1, shift 2, shift 3. So in row mein kya hai? Shift 1, shift 2, shift 3. So we have to select this shift C4 wala column jo hai na. Select that. Everybody with me till now? So you have to select summarize data in this A, B, C, D select karo. In row mein shift select karo. Okay, now don't click on OK yet. Go to chi-square and click on chi-square test here. And you can click on expected cell counts. The expected cell count calculation we have done now, so that also will come. Okay, just do this, two clicks and say OK and say OK. Now click on the sessions folder, scroll up, and you can check the Pearson chi-square value, which is this p. Just change this p value 0.004. Now you can see this table. You can easily understand this table now. This is actual value. This is expected value. Actual value, expected value. All right. So now just try to understand this, guys. Just try to understand this. If you observe very closely, what we are actually checking is the proportion defect, right? So you can see shift 1 has 94 defect, shift 2 has 96, shift 3 has got 119. So 94, 96 does not have much difference, but 119 has a very big difference, right? That's why the p value, which is less than 0.05, indicates the difference is statistically significant. Are you clear? Just give me yes in the chat box. सबको मिला ये p value? Super, super. So it requires a little bit of practice. If you are doing it first time, seems to be a little overwhelming. Okay. We are just revising the content of the black belt quickly. There are multiple hypothesis testing, whichever is useful, whichever is required, that you should be. So are we using all this hypothesis testing every time? The answer is no. Whenever it is required, you have to use it. Okay. Like for example, when the doctors go for the medical study, okay, they study all the diseases. Okay, but do they practice all the diseases? No. Even 80-20 principle is applied over there. 80 to 20% of the diseases will come 80% of the times. All the same general physicians will be curing, the simple cough and cold and fevers and viral infection. These are the common disease pattern, or the indigestion, the stomach disturbances. These are very common types of diseases which will come 80% of the times. Similarly, these additional things, why we are learning, if that situation comes, we should be able to handle that. That's why we are basically learning these advanced hypothesis testing. Okay. But basically, we will go for 1, 2 sample t test, 2 sample t test, ANOVA, etc. The basic stuff will be more useful and more used. Clear? So that's clears our hypothesis testing. We will take a quick break. Okay, guys, what we'll do is we'll just take 5 minutes break. It's 8:35. We'll be back at 8:40 sharp. Okay, and we will start the session. For the people who have just joined in, we are just playing the last, hackathons recording right now because my throat is not good today. Okay, so we'll take a quick break of 5 minutes and we'll be back at 8:40, and we will be covering regression, advanced regression today. Okay, yes, thank you very much. Hope everybody's back. Just give me the confirmation that you're back, and let's begin our next part of the journey, which is the advanced regression. Yes, thank you very much for the confirmation. Everybody can just give me confirmation quickly. Thank you, thank you, thank you, thank you. Everybody got it? I have not yet received everybody's confirmation. Just give me a quick yes that you are back on your table, on your chair or whatever. Thank you very much. Thank you very much. Okay. I believe everybody is back. So we are the second type of hypothesis testing. Basically, we learn it's called as regression and correlation. Okay. So we already have seen the basic correlation regression activities in our green belt level. There are basically three types when it comes to correlation. The first is called as positive correlation. What is correlation? If I have to plot a graph like this, okay, let's say how much time do I study? So let's say study time and my marks in the exam. Okay, so more the study time, more will be my marks in the examination. So if I plot the study times and the marks, I will see a positive trend going up left to right. Okay, that's called a positive correlation. On the second type, this, let's say, for example, time spent on social media. Let's say time on Instagram example. Okay, so if somebody is spending more time on Instagram, so the graph will look like this. More the time you spend on Instagram, so this is the x-axis, this is the y-axis, lesser the marks that student will score. It is called a negative correlation. And there's a third type of correlation, which is called as no correlation. For example, what will be the example? Let's say my attendance in my college or school, that has got no correlation with my score, because whatever my attendance, my score has got no relation, right? I can be attending all the sessions, but I may not be giving focus. Or somebody who is not attending the sessions, but he is studying very hard. So the marks may not have any impact. So you can say there is a no relationship, no correlation, right? So we have all seen that. And along with that, we have seen so this is called correlation. Correlation is relating the x and y. X is this, the x-axis pe x hota hai, which is the independent factor, and y is a dependent factor, right? So we want to establish a relationship between x and y. Along with that, we have seen a equation y is equal to a plus bx. Everybody remembers this? Just give me a in the chat box. Okay, y is equal to a plus bx. You remember? Y is equal to a plus bx, where a is intercept, CEVT, and b is equal to slope. Y is equal to a plus bx. Y is the output, a is intercept, b is the slope, and x is the input variable. So what is intercept? Let's say, let's look at this example number 1. So if I extend this line of best fit which passes through these dots, if this line is extended, this intersects the y-axis, and this is called A. This point is called A. This point, it's called intercept. Okay, and slope is what? What is the difference your x is making on your y? So what is the difference with 1 unit change you are getting on your y? For example, let me give you a simple example of test of tea and sugar. Okay, I'm explaining you the slope. Okay, so test of tea test of T is measured on the scale of 1 to 10. Okay, so this will be, let's say, test of T, 1, 2, 3, 4, 5, 6. And instead of study time, we will take sugar. Okay, now sugar will be measured on tablespoon, 1 tablespoon, 2 tablespoon, 3 tablespoon, etc. Okay, so 1 unit is equal to 1 tablespoon. So the moment we had no sugar, the test will be a little less or maybe 0 or whatever. Okay, then we add 1 tablespoon sugar. So there will be a little test will go up. Then we add another tablespoon, 2 tablespoons, then 3 tablespoons. So the test might go a little up. So what is the deviation we are getting on our y, which is the test, with 1 unit addition of x? That is called scope. That is called slope, not scope. Slope. Slope is nothing but what is the deviation on y we are getting with 1 unit change in x. That is called as slope. And all these basic fundamental we have seen in our green belt level. There is another value which is called R square value, which shows the strength of the relationship. Okay, strength of the relationship. For example, if everybody's clear with this, yahan tak sabko clear hai ye? I'm just revising the green belt stuff. We have seen correlation regression in green belt. I'm just quickly revising it so that we can go to the advanced level. Everybody's clear till now? Just give me yes in the chat box. If you have been through the green belt correlation regression, this will be very simple to you. If no, then I would recommend you go back to the green belt wala stuff that will give you the clarity. Just give me yes. The people who are already in the black belt level, this is a quick refresher for you guys. Yes? Very good. Very good. Now, apart from that, there is something called R square value. Let me just recreate this. Now, what is R square value? Let's say you have something like a data set like this. Very, the points are very close to the line of best fit. And there is a second scenario where the dots are a little spreaded across to the line of best fit. So here in the first case, the R square value would be maybe 90%. Here the R square value would be around 60%. Let me give you another scenario where, there is no relationship like this. So R square value would be maybe 2%. So R square shows the strength of the relationship between X and Y. If it is tightly bound, that means the strength of the relationship of X and Y is very strong. So very high impact of X on Y is there. Just like, we have few friends who are very close friends. So if we draw that would be very high R square value, very close friends. There are few friends who are just, we meet them once in a week, once in a month, etc. The R square value, that bonding is not there. Much bonding is not there. R square is less than, a little medium. If somebody who, just know him, there is no much connection, then the R square is very low. So that's the third option. So this is how the R square value is calculated. So R square also shows the strength of the relationship. Okay, this is also covered in our green belt level. Now let me share with you a file, and we will, take this calculation further. Okay, I'm just sharing a file called Minitab regression. Just open this file, and we will go for some other kind of regression. This is the basic regression we have already seen in our green belt. Just open this file quickly. And once you open the file, please let me know. All right, so here, till the time you open the file, let me just explain you this file. The first column, the expansion, and the second column is temperature. So do you remember we used to, in the physics 8th or 9th standard, we used to do one experiment. Okay, there used to be a metal ball okay, which used to pass through a ring. There was a ring like this, and a metal ball used to pass through this ring very easily. Okay. After that, we used to hit that metal ball with the help of candle or with the help of some flame, right? After that, that metal ball will expand, right? Because of the hitting, there is more energy to the atoms and molecules, so the structure would expand. So after that expansion, that metal ball would not go inside the ring. Now that's a clear cut, what you can say, a clear cut proof that there has been expansion of the metal ball, right? So similarly, what they have done, they have taken a plate, okay, and they have heated the plate. They have given some heating to the plate, and whatever expansion they are observing, whatever expansion in the length they are observing, they have kept. For example, they have heated, they have given temperature 24 degree, and they have observed 0.591 expansion. They have given temperature this is the expansion, like that. Okay, so this is the data. So what is the y here? Just type expansion E in the chat box or T in the chat box. What is the y? Is expansion the y or temperature the y? You should be very clear. Y is the output. Remember this. Always y is output, x is input. What is my y here? Everybody, give me the answer quickly. Is my expansion y or my temperature my y? Very good. So my expansion is my output and my temperature is my input. Once I give my temperature as input, then only my metal will expand, right? That has to be checked. So expansion is the output of the input of temperature. Clear, everybody? So now we will go for our basic regression. I will go there, go to stat, regression, fitted line plot. Everybody do this. Stat regression fitted line plot. Just click on this. Now in response, select expansion. In X, select temperature, select linear model and click on OK. I repeat once again, go to stat. The second option is regression. Go to fitted line plot. Once you click on fitted line plot, Y may expansion, predictor X may temperature, and click on linear, click on OK. And you will find this kind of a plot. Everybody got this? Just type yes in the chat box. Very good. So we all have seen the line of best fit. We have seen the R square value 68.9. We have got this regression equation y is equal to a plus bx. So here you can see this is a is 7.449. If I extend this line to here, this will be 7.4, and this is the slope, okay, which is 0.021 temperature, right? So this is the equation y is equal to a plus bx. With this equation, we can predict any value, any expansion. For example, if I want to predict what will happen if I give temperature 700. So if I add 700 here, do the multiplication, I will get this expansion I can predict. Okay. So this is the basic stuff which we have seen. Now let's go to the different one. Let's go back to the command window, which the edit last dialog box, which we call it as. Okay. The the shortcut is Control E. If you press Control E, you will go to edit last dialog box. Now here there are two other options available as well. Instead of linear, which is the basic stuff we have seen in the green belt, let's go to quadratic. Okay, एक बार click करके देखते, then I will explain you. Just click on quadratic, the second option, click on OK. And now you can see something has changed. Now what has changed? Just try to understand this. What has changed? There are two changes you are observing. There are three changes you're observing. One change, instead of a line, earlier was a line. Now there is a curvature. You can see a parabolic curve here. Okay, so that is first change. Instead of a line, there is a curvature. R square has increased from something around 60% to 87.8%. And the equation also has changed. Are you understanding? Equation also has changed. What has changed? Let me explain you. Let me explain you again. Okay. First, again, go back to the Control E. Just press Control E. And now just select cubic equation. Click on OK. And now the first was linear, quadratic, and cubic. You would have seen three different scenarios here. Okay, let me just quickly put all these three diagrams with each other. ये linear है, इसको भी हम लोग छोटा करते हैं so that you can shake that out. Okay. Linear हो गया, ये हो गया quadratic, and हमें चाहिए cubic. So तीनों भी आपके सामने रख दिए. Let's see here. Okay, let me just reduce it further. So this is see the difference between these three. Okay. What is the difference? Just try to understand this. The difference is the equation, regression equation. What is the difference between regression equations? Let's try to understand this. So linear, write this down. Linear equation would be, what is the linear equation? Y is equal to a plus bx, right? Quadratic equation would be y is equal to a plus b1x plus b2x square. And what would be the cubic equation? Cubic quadratic equation is where the square terms are there. Okay. And cubic equation is where the square plus cubic terms, which is raised to 3 terms, will be there. So the equation will be like this: a plus b1x plus b2x square plus b3x cube. Now, when I say b1, b2, these are various slopes. Now, if you can see here, when it comes to the linear equation, the slope is only once. Only one slope is there, right? It goes like this. But for the curvature, there are multiple slopes. For example, you can see here, there is this one is the slope 1 and this one is the slope 2, right? That's why if you observe very closely, slope 1 is a positive slope which is going upwards, and slope 2 is a negative slope which is going downwards. Whereas in the third equation, you can see this is slope 1, which is a positive one. Then you can see the slope 2, which is a little going downwards, which is a negative slope. And this is a slope 3, which is again a positive slope. Can you see here? B1 is positive, B2 is a little negative, and B3 again is a positive slope. That's why there are 3 different slopes which have been calculated with square and cube terms. Are you clear? That's why this equation, and we don't have to calculate it. Software calculates it for us. And these, with the help of this prediction equation, we can predict the value of one variable with another variable. Are you clear with this? Just give me yes in the chat box. So in the basic regression in the green belt, we have seen linear. in quadratic and cubic, we have seen in the black belt level. Okay. Very good. Very good. So start using these equations as well. Start using these regression models as well. All right. Super. Now, still this is 1x and 1y. Na? Still it is 1x and 1y. What if we have one output and multiple x's? Okay, that's where our matrix plot comes into picture. All right. So let me share a file with you and then we will understand a matrix plot. Let me share a file with you. Okay. Just open this file called matrix plot. We will understand matrix plot. Let me also open the file for you guys. The name of the file is stamping matrix plot. Okay, so you can just open that file and we'll see where there are multiple x's. How do we deal with that? Okay. All right. Once you open the file, please let me know. Meanwhile, let me just explain you the background scenario of this. So the file looks like this. Imagine, let's say there is a machine. Okay, so there is a machine. There is an operator. And this is the input and there is the output and there is some defect coming in. Okay. So what they have done is in the machine, there is a cutting tool. Okay. There is some tool which cuts the, let's say, metal. Okay. Or give the shape to the article. So what they have done, the factors they have used. So this is defect fraction, which is their y. And there are multiple x's. X1 is the age of the tool. So for this tool, what is the age? Then temperature of the machine is x2. The speed of the machine is x3. And experience of this operator is x4. So these are multiple factors they have considered here. And they want to check what is the impact on my defects. For example, this defect is 0.0410. That means 4.1% defect. In the first run, they have kept 45 as a tool age, temperature at 198, speed at 50, and experience is, let's say, 21 weeks or 21 months, whatever. Okay. So this is the experience. And at that point, the defect fraction is this. After that, the settings are this. And the defect fraction is 0.0425. That means 4.25% rejection or defects. Okay, so this is the data we have. So now we want to check how multiple x's can impact on y, how we can check that out. Clear? So for that, we have a tool called as matrix plot. Matrix plot. How do we do that? Go to graph and below scatter plot, there is something called matrix plot. Just click on that. Graph, the second option is matrix plot. Once you click on that, select the simple one. Select the simple one. Click on OK. Now here, there is very interesting way you have to select the data. Okay. How you will select the data in the sequence x1, x2, x3, x4, and then y. First x1, x2, x3, x4. You can change the sequence of x1, x2, x3, and then the y. Okay. So here, let's do this. Click on here. Double click on tool age, then temperature, then speed, and then experience, and then you double click on y, which is our defect fraction. Okay. Before clicking on OK, there is one small setting we have to do. In the matrix option, we'll go to matrix option. And in the display, matrix display, instead of full, we select lower left. Okay, I'll explain you what is that. Instead of full, we select lower left, click on OK, and click on OK. And this diagram will come. This is called as a matrix plot. Now let's try to understand how you can read this plot. Okay. Now there are, so let's try to understand this. This is called tool age, which is X1, temperature, which is X2, speed, it is X3, experience, which is X4, and a defect fraction, which is Y, right? So we have to see this, the bottom level graphs. This is the graph number 1 of tool age and defect fraction. This is graph number 2, which is temperature and defect fraction. Graph number 3, which is speed and defect fraction. Graph number 4 is experience and defect fraction. Okay, now try to understand this. Graph number 1, you have to give me the answer yes or no. Is it positive or negative correlation? Type positive or negative. Just give me a sign, plus or minus. P, right? Positive, everybody? Correct? What about second and third one? Second graph and third graph? Positive or negative? Again, positive, correct? They are even strong positive correlation. So here, if I have to check the R square value would be maybe around 65 here. Here the R square will be 97. Here also R square will be around 98. Very strong correlation. Can you see there? It's the difference. If the data is very tightly bound, then the R square is very strong. Okay. Let's come to the fourth one. Experience and defect fraction. Now tell me, what is the relationship? Positive, negative? What is the relationship of experience and defect? Negative? No correlation. Very good, very good. So if you see a scattered pattern like this, it shows no correlation. Okay. Now understand this. How many times we assume that better the experience of the people, lesser will be the defect? Yes or no? Just give me yes or no in the chat box. We assume, no, with our experience, more the experience, lesser will be the rejection. That is but the data does not support our assumption. Understand this. Okay. Yes. Data does not support this relationship. How do we need to identify positive or negative? Can you please explain? See, very simple. Very simple. Let's say, for example, let's take the same example of our test of the tea and sugar. Okay. So this is, let's say this is 0, 0. This is 0 0.1, 2, 3, and 4. And this is my sugar. And now this is my test. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is my test rating. Okay. Now, when I had no sugar at all, and if I give the cup to the customer will give me the rating, let's say 2. So the first one is here. Then I will add 1 tablespoon. Customer will say, okay, it has improved to 3 now. So I will plot 1 tablespoon, the rating is 3. If I add another tablespoon, 2 tablespoons, customer says, okay, now it is 5 rating. So at 2, it is 5. If I add another one, customer says, okay, it has now moved to 8. Now, if you observe very closely, I am getting as I'm increasing my sugar, my Y is also increasing. That is called a positive relationship. Okay. Positive meaning my X is also increasing, Y is also increasing. That is called positive relationship. Clear? I am studying more, I am getting more marks. Positive relationship. So whenever you see a pattern like this going from left to right on the higher side, that is called a positive trend. You can see 1, 2, and 3 graph from the bottom are positive graphs. Are you clear, Narsimhaji? Just give me yes in the chat box. Same goes with, let's say, if I have to draw, let's say, super clear. Now let's say the same thing for the water. Okay, let's say water. Okay, अभी water का कैसे होगा? Water का कैसे होगा? Let's say, for example, let's say the same cup of tea I want to make. So one, what you can say, one cup of water. Okay, see, I don't make tea very regularly, so please pardon me. Okay, I'm just giving you example. 2, 3, 4. Now these are the cups of water. Now when I have 1 cup of water, okay, so customer will say, okay, rating is at 6. Now for the same cup, only 1 cup of tea, I have added another cup of water. Now my taste will go to 4. I add another cup of water. My taste rating will go to 2. That means I've just made, just I keep on pouring water. My taste will go deteriorated. That is called, I'm increasing my X, but my Y is decreasing. This is called negative correlation. Okay, so positive meaning once my X is increasing, my Y is increasing, positive relationship. My X is increasing, but my Y is decreasing. That is called negative relationship. Are you able to understand this now? Yep. So this is how you can use multiple X's in one Y. Okay. Now, where you can use this, where you can get the equation here. Where you can get the equation? Let's go for equation. Let's go to stat, regression, fit regression model. Okay. Stat, regression, fit regression model. Just click on here. And in the response, you select the defect fraction. And in the predictors, you select all those predictors. Okay, tool aging, temperature, speed, and experience, all those factors you select and click on OK. And here you will get a regression equation. Can you see the regression equation? Defect fraction equals Y is equal to A plus, the slope into factor number x1, slope 2 into factor number x2, slope 3 into factor number x3, and slope 4 into factor number x4. So you can get the regression equation over here. And this is called multiple regression. So you can do multiple regression as well. Okay. Tomorrow I will show you something very interesting, how you can play around this multiple regression, which is called as optimization. Okay, so tomorrow is a very interesting topic called design of experiments we are going to learn. Design of experimentation is amalgamation of all these, basic statistics, hypothesis testing, regression, multiple regression, all these things are amalgamated in advanced tool called design of experimentation. So are you clear with this hypothesis testing and regressions today? Just give me yes in the chat box. Super clear. Again, it requires practice. So you check this recording once again. I will give you the recording. All right. I have already shared the recording of day 1, yesterday's recording, right? So check out that. Today's recording also will be uploaded in the Black Belt Hackathon. You can check out that recording. Okay, we'll share that in the community tab as well. Okay, you can please check out. I will put all the files which we have used today in the Minitab exercises below the recording as well. So you can please, you can just scroll below that. Okay, recording ko scroll karo niche, video ke niche, you will find all the files. You can download them and just practice. Just start the recording and practice along with you so that your fundas will become clear. Okay. So I think we'll stop today. We'll tomorrow connect again at 7 p.m. sharp for the topic called design of experiments, which you will learn, and you will learn a lot and you will enjoy that as well. Okay. Any question which is unanswered, please let me know. You can ask the question later on the mentor's number as well. We'll answer that as well. All right. So thank you very much for coming after your very hard working day. You guys are joining this, 2.5, 3 hour session. It's amazing, really appreciable. See, Black Belt is a little advanced. Okay. So the new members can feel a little overwhelmed. It is absolutely normal. Okay. But why I specifically mentioned do not skip this, because as you going through this 60-day challenge, okay, anyways you are going to come across these tools, right? So when you will basically start learning this, you will immediately connect the dots. That's why at least एक बार आपके कानों के ऊपर ये सब जाना चाहिए. At least you should hear this terminology, okay? Curvilinear regression and cubic regression and all these things, okay, quadratic equation, etc. So once you will go to the black belt level, then you will understand, okay, this is where I remember hackathon में हम लोगों ने सीखा था, right? So that's the objective of this. And yeah, thank you very much, Narsimbaji. Thank you very much, everybody, for connecting. We'll connect again tomorrow with the same enthusiasm. Till the time, keep learning, keep growing. This is Dinesh Patil signing off. Bye bye. Take care. Good night.